Today we're going to be talking about pure substances and mixtures and the differences between them. So to start, all matter can be categorized as either a pure substance or as a mixture. Okay, pure substances are chemically combined, and that consists of elements and compounds. And then mixtures are things that are physically combined, things that are not chemically bonded together. And that has to do with either homogeneous mixtures or heterogeneous mixtures. And we'll talk about some other types of mixtures as we move through the year, but let's focus on these two types right now. So pure substances, like we said, are going to be chemically combined. So elements are the most basic type of pure substance, the most basic substance, and they're made up of only one type of atom. Okay, so it's only one type. All right. Of those types of atoms, you can still have an atom or you can have a molecule. Okay, something called a diatomic element is what happens is when you have two of the same type of atom, right? Two of same type of atom. And they naturally occur that way, and there are 7 of them that do that. Oxygen is one of the most common ones that we know about. It's O2, not just O. Okay. There are 120 elements on the periodic table as of right now, and people are working to create more. But that's a very difficult, time-consuming, expensive, and difficult process. So there are a number that are man-made, and most of these we can just find within our natural atmosphere. Okay, so let's talk about the element symbols. So element symbols like H for hydrogen, He for helium, C for carbon. Those symbols are either 1 or 2 letters. For many of them, they're 1 letter. However, if you have something like hydrogen and helium, the H has already been taken for hydrogen, so we use a second lowercase letter to help describe helium, He. So you'll notice that you'll have a number of different combinations. Okay, and that's also a clue that will help you know you have a new element is if you have a capital letter. All right, so elements are kind of the building blocks of the rest of what we're talking about. Okay, compounds are when we have more than one type of atom. Okay, more than one type of element. So water is a great example of that. Okay, that's something we're very familiar with, H2O. And what this means in this formula is we've got a capital H and a capital O, so we've got 2 different substances. Okay, we've got hydrogen and we've got oxygen, all right? And the little 2 reflects that there are 2 of these hydrogens, okay, 2 hydrogen atoms. And there's no 1 here, but that there's nothing there implies that there is 1 oxygen atom. Okay, so 2 hydrogen, 1 oxygen. This little 2 here is called a subscript. Sub meaning below, script meaning writing. Okay, so that's a subscript. It's not a square like in math class, it's a subscript. Okay, so sometimes we also will say things like 3H2O. And what that's telling us is that there are 3 water molecules. Okay, so if I draw a little water molecule, that's my oxygen, and those are going to be my hydrogens. That's 1 molecule. Now this is a second molecule, and now that's going to be a third molecule of H2O. All right, so this is 3 H2O molecules. So in total, there are 6, 3 times 2, 6 hydrogen atoms, and there are 3 times 1, 3 oxygen atoms. All right, so that will help us be able to tell how many atoms are each. But you have to remember that they're chemically combined in this form. There are 3 separate molecules. Our diatomic elements that we mentioned, I'd like you to draw a little periodic table right on your note page. There are 7. They start with element number 7 right here. This is element number 7, which is nitrogen, and they make the shape of a 7. There are 6. NOFClBrI, and then the +1 is hydrogen. So we say that these are part of the 7+1 club. And that's a nice way of us remembering what our diatomic elements are. Remember, our diatomic elements naturally occur as a pair, so with 2 atoms. All right. Now we're going to move over to mixtures. So we have 2 different types of mixtures. We have homogeneous mixtures and heterogeneous mixtures. A homogeneous mixture is a mixture that's uniform in composition throughout. Okay, and a heterogeneous, it's not uniform. It might have layers. It looks like you can separate it. It doesn't look the same throughout. So it's important for us to know about mixtures that mixtures are not chemically combined. Okay, so they can be separated by physical means through filtering, through decanting, through magnetism, through evaporation. Okay, so if you can separate it physically, that's when you have a mixture. Okay, so 2 things are not chemically bonded together. All right, so homogeneous, the mixture looks the same throughout. So I'm going to draw on this milk here, which is homogeneous. And we have water particles, okay, that look like this. I'm just going to draw 4. Right? And then if I have X's that are going to represent the fat in the milk, right? The fat is moving in between the compound, but they're not chemically bonded. Okay, they're just sharing the same space. Okay, homogeneous, the 2 either elements and compounds, they share the same space. For heterogeneous, the particles are so big that they actually separate themselves, or their characteristics are so different that they separate themselves. So we have mixtures that don't look the same throughout. All right, so what I'd like you guys to do is I'd like you to do some practice. This is A, B, C, D, E, F, G, and H. So label practice A through H, and decide whether each is an element, a compound, or a mixture based on the particles here. For the second part, what I'd like you to do is look just at the chemical formulas that I've given you, and I want you to decide if these are an element, a compound, or a mixture. So same thing, right? Chemical formulas, 1 through 5, and then decide, is it an element, is it a compound, is it a mixture? How will you know? All right, give it a whirl, and we'll go over it in class tomorrow.